Hello there, my name is Wedira Wangui from Kodarasa, and today we're going to be covering SQL Joins. We've done a lot of sessions on this, and today we're going to do a video that is more intermediate. And yeah, welcome. I hope you enjoy. Let's jump right into it. We'll start with different types of joins. We have inner join, we have full join, we have self join, we have right join, we have left join, and within also the left, right, and full join, we still have a null check where we get to ensure we only get the values that do match the null part. Anyway, so let's look into it. So basically, an inner join covers all the rows that match from both tables. So records from this table and this table, as long as they match, like the key matches, then you bring them in. Let's look at an example of that. Back to our database, we are asked fetch all the students in their classroom. So here, I need the student and also the classroom they are assigned to. So I do need them to, all the records that match in both tables. So I have a query here, select all these details from student and then from classroom. Inner join classroom on classroom ID and cr.id, which is the column, the primary key on the classroom side. So when I do this, I'll be able to get all the students and the different classrooms they are assigned to. And we can see here, we have all these students and all the classrooms they are assigned to. Similar to that, this is a query we did when we were starting over. I asked, a question was fetch all the students that belong to a classroom called Kifaru. So same query, except now we add the where clause and add classroom name is equals to Kifaru, and that will give all the students that belong to this classroom. So I hope that's clear. So basically we've joined the two tables and gotten the records that match from both. There's no null values here. So another example similar to that is give me all the students in the class. I can do that. This is very similar to what we had, and you can see all the students in the class they belong to. And also similar to the Kifaru one, fetch all the students from the class of 2014, and I do the same and then just add a where clause where the class name is equals to class of 2014. Let's continue. Fetch all the students in their duties. Again, a join to the duty table, and then I get all the students in the different duties they are assigned to. One last one. This is also a query we did when we were setting out. I asked for us to fetch all the students that work on the social hall, like whose duty is the social hall. We have that, and we have 3 students who are Gatabaki, Kendi, and Mukidi. So that's our inner join, ladies and gentlemen. Let's go to our next type of join, which is the left join. So basically, when we do our join, we want all the records from the left table and the ones that match on the right table. So in this case, if you don't, like I have all the records from this, and if they don't fully match on the other side, have them as nulls. But give me all the records from the left side and the ones that match on the right side. So in cases where there is no actual match, then those values will be set to null. Let's look at an example. So basically, everything on the left and then what matches on the right only. Left join. So select an example would be, give me all the students and their duty. Give me all the students and the duties they are assigned to. So let's use this time. In this case, I said all the students. The other case, we matched students, and so it was not a requirement to have all the students. In this case, fetch student and their duties, students and their duties. So this, in this case here, it would be fetch all the students, emphasizing that I need all records from the student table and their duties. So in a case where we don't have a match on the other side, we'll get a null. Let's look at that. So we see all the students, and then at the bottom we have these 3 students, Muiga, Mutethi, and Gatweri, whose duty is null. So it fetched all the students. That's everything on the left side of the left join, like the table to the left join clause, and then anything that matched on the duty side, and anything that didn't match ended up becoming null. So that is left join. But then there's also left join with null check. So as you can look at this circle, we're covering everything on the left and what is joined on both. I think it's clear what the left join does. We also have left join with null check. So this is basically what we just had, except give me only the ones with null values. So in this case, they won't have matched, like all these rows that we returned here that were null. So we had the ones that match, and then the ones that don't match, and they were null. So when we have a clause for when, of course, that is null, then we're given only the ones that are null. Similar to that, this gives us all the records that match, and then excludes the words that don't match. So in a sense here, it's doing an inner join. So anyway, you also have an option to either include the nulls or exclude the nulls. That's what I was trying to express. Similar to that, we have the right join. So the right join picks everything on the I mixed the colors, sorry about that. Anyway, the right join picks all the records on the right side of the table on the right side of the right join, and then matches it with what's on the left. Similar to that. So what has changed is just the positioning and the clause right, really. So we have a query here, select student first name, last name, and then the duty name from student, right join duty on duty ID. So here the duty is on the right. That means we need all records from the right first, and then anything that matches to the left. Let's look at that. As you can see, we have all duties, all of them listed here. We have this duty here called classrooms, and it doesn't have a match on the student table, so we have null on the student side. Similar to that, we can do a null check to just get that. And of course, if it's not null, we'll only get the ones that match, which is similar to an inner join. So that is, we've covered inner join, left join, and right join. Now we have, and also right join with null check and left join with null check. We have full join. So full join, give me give me what matches between the two tables, and then give me the rest from this table and the rest from this table. So basically all values from this table, all values from this table, of course, with what matches between the two included. So here we'll have all those nulls we had when we did the left join, and the nulls we had when we did the right join. So as you can see here, we have these three where the student did not have a duty and where a duty did not have a student assigned to them. So basically it added the ones that matched for both, and then the rest from this side and the rest from this side. As always, you can also do the null check. So here we have just the ones that matched null for both sides. Yeah, so that's basically for inner join, left join, right join, and full join. And actually the ones you'll end up using most are inner join, left join, and right join. Also, we've seen a case where we get to include the ones that do match and the ones that don't match. So we've done full join, right join, left join, and inner join. Let's move on. We have another one called cross join. So where does cross join come from? Like, what does it do? It basically does a Cartesian product. So you give it two tables, it will multiply all the rows by this side and this side. So if I have one teacher and five classes, because I'm using teacher and class here, maybe I have two teachers and 5 classes. it will multiply, like it will multiply each side by each other. Like, so let's actually look at an example. First, before we do this, let's look at what is under teacher. So select all from teacher. So under teacher, we have 6 records. We have 6 teachers. And then let's look at select all from class. Class seems to be a protected SQL value word. It seems to be a protected word, that's why it's highlighted differently. Anyway, so you've seen we have 3 classes and we have 6 teachers. So what it will do will be literally a multiplication, a Cartesian product. So we now have 18 records. We had 6 teachers and we had 3 classes. So we'll have them multiplied and we end up with this. So what are the cases when to use a cross join to begin with? One, you use it when you don't have a join between 2 tables, and try to use this for less values. It doesn't make sense for you to be matching 20, like a million students with 20, 25, like it doesn't make sense to even do such a query in the first place. So choose it when you have no way of joining these 2 tables, and also aside from that, 1, no way of joining them, and 2, when you have less records. Yeah. So that's cross join. We have another one called natural join. So natural join is interesting in that depending on what you're feeding it, so it's basically a normal join, yes, but you're not giving it the join condition. As you saw for inner, right, left, and full join, we're giving it a condition. So the clause says select, you list the columns you need from the table, join. Oh, another thing to note, sometimes you'll see join and not inner join. So when you see join alone, assume that is inner join. That's the default. When you just see join, so that means inner join. Anyway, but I digress. So as you've seen in these ones, they all had a join clause, like a join column. So when it comes to natural join, you won't have the same, and because of that, it tries to match 2 columns from the 2 tables or whatever you're joining with. If it's 5 tables, because you can do all these joins for more and more tables, of course. So what it does is it tries to get a column that matches, a column name that matches, and when it doesn't, then it's hard to guess what it will do. Let's take our example here. We've already seen what teachers and what class are. When we try to do a natural join on them, we get this bizarre response where we have 3 classrooms, and then we only picked 3 teachers. So it seems to have done a join, but doesn't make sense what it did. Same case, we have another example here. It only picked all the subjects and then matched them to the subject teacher side, but you don't understand what it did. But let me give a better example. So we are going to go to a whole new database. We're using the school management system. So I tried to create sample tables here. We have orders and we have product. You can see ID, order date, product ID. This is key and quantity, and then under product we have product ID, product name, and product description. So when I do a join between these 2 tables, you can already see that there's this common column name, which is product ID. So let's look at what is under orders. So under orders we have 6 records, and we have 6 values and the different dates, the different quantities, and the different product IDs. And then under product we have 3 different products: Kiwi, Sunlight, and Azam Cola. So when we do a natural join in this case, remember we have a matching column in this case. So what it seems to have done is now it does an inner join. It uses product ID as the join key and then joins the two. So you've seen the records here, 1, 2, 3, 1, 2, 3. This is because under orders we did have 6 records, and then we had 3 products. So that's what's happening here, and we can verify this by doing an inner join using that key, join key. So select all from orders, join product on orders.product ID is equals to product.product ID, and we have the same output. So basically what I'm trying to say is, for natural join, again, try to avoid it unless you're sure that the columns match. But then even when you're sure the columns match, a lot can happen. Someone can come and change the columns unknowingly, and then that impacts your query. So you want to avoid that if you can. Try to be very explicit so that anyone that comes in future knows what is happening, instead of relying on good faith. Yeah, so the last type of join I'm going to cover is a self-join. So a self-join comes in when you're trying to get maybe some sort of inheritance or like a relationship between this table and records within this table. So an example would be, for instance, in an employee setting, we can have an employee have managers. So maybe I want you to give me all the employees and their managers. So for instance, here we have a table employee ID, name, profile, and then the manager ID. So we do have the manager details and we have the employee ID details, but I don't have the manager name and the employee. So I'll need to match back to this same table on key manager ID, and then after doing this matching, then fetch the employee name who's now the manager. So let's look at an example of that. We have so we're basically joining employee to itself. One, we're giving it an alias of E, and the other one, we're giving it an alias of manager. And you can see we're using a left join here because I want all the employees and anything that matches on the other side. So this leaves room for an employee to not have a manager. If we had used join or inner join, then we wouldn't have employees that don't have managers, but we want all the employees and their managers if they exist. Employee E, and then E.manager ID, and then matches on M.employee ID. Let me run this, and we'll have all these. We have manager. So in this case, Kenya, as you can see, has no manager, and of course, because they have no manager, they also have no manager ID. Kenya is a manager to Mugendi and Kadhokomi, and Mugendi is a manager to Muswachi and Tinyori. So that's what happened. So just to play with it, let's say we had used join instead of left join here. We would not have gotten Kenya's record who has no manager. So that was just me trying to illustrate the advantage of when to use, like really when to use inner join and when to use left join. And that's it on joins. I hope you learned something. Feel free to ask questions and I'll be sure to check them out. Thank you and have a good day. Bye.